I'm eventually going to want to find the minimum cost. So all these steps wouldn't be here. It would just say you have a rectangle area of 20 square yards that you want to create. What's the dimensions that would minimize the cost of that given these costs, right? That's all I would say. So up here, you have a rectangular space. What do you guys want to label these? What's this here? I would probably label this Y, knowing me. You can label them L and W, doesn't matter, right? Make that a Y, Jeff. You could do it. There you go, buddy. Now, if you didn't do that, it doesn't matter. Variables are just dummy things. We just put them in to take the place of stuff we don't know. So what's the area? XY. It's crazy. I like it. Now, to create this area, we're going to use fencing that costs $10 a foot on 3 of the sides. And I want you to realize, what I just drew is one example. It doesn't mean this is how it actually looks. So it doesn't matter which 3 sides are $10 a foot. Not a damn bit. It doesn't matter if you call these 3 sides or these 3 sides or these 3. Right? The math is going to work out. You guys kind of with me? So somebody sitting next to me had these 3 sides are 10, but I had these 3 sides are 10. Our X and Y values are going to be switched. Still going to be the same rectangular area. Right? Guess semi with me? Okay. So if 3 sides cost $10 a foot, let me just say these 3 sides, just to say something. So that would be 10y plus 10x plus 10y. And $15 a foot on the last side, so that would be 15x. That is my cost function. Does the perimeter of this rectangle ever come into play in this problem? No. They're not asking me to minimize or maximize perimeter. They're asking me about cost. Let me stop here for a second. You guys see how this kind of goes? So it's just layers of stuff. So now I got a picture to work with. I can throw this information in. If you didn't get the same thing I'm about to get, you're fine. So I get 20y plus 25x. Some of you guys might have gotten 25y plus 20x. It don't matter. Maybe. So now, given that the area is 20 square yards, so 20 equals xy. I say solve this for length, but it doesn't really matter. I just didn't want to put a letter here. So if I solve it for y, I get 20 over x. So this is what we almost always do. They tell me something for sure. I solve that for a letter so I can throw it into the function I want to work with. And I want to work with the cost function. Replace that in the cost function. So now the cost is going to be 20 times that plus 25x. So that's the function I want to work with now. Okay, I like it. And now I just attack that. I can't do this in pre-calculus. Not by hand, but now we're in calculus. We can do this stuff by hand. So, of course, how do I find the minimum of this? What do I have to do with this? Take the derivative, find the critical numbers. I like it. So go ahead and finish that out if you haven't got there yet. catch up to you guys. Is that cool? Now, right now I can see one critical number, and why is that a critical number I would just throw out? What critical number can I see already? Where do critical numbers happen? Where the derivative is or undefined. What makes this undefined? If x is 0, though, what kind of shape do I have? I got a line. It ain't going to contain shit. I put my orc next to a line. It's like, this way. Right? Yes, maybe. So that is one extreme. That would be the minimum area. There's no area there. Right? So that's not good. So that I ignore that critical value for 0. Well, how do I get the other one? I set this equal to 0. One of the coolest little things to realize in algebra is just to switch these. And 400 divided by 25 is 16. I like it. And so I get x equals 4. I'm going to throw negative 4 out because, again, it would be very difficult to construct something with negative side length. All right? The minute you do that, let me know. I'm going to stay away from that thing because shit's going to happen. I don't know. So what does this have to do with the question? I mean, have I answered the question yet? No. So, what do I do?
Plug it into that area.
Plug it in where? What's the question asking, though? Oh, find the dimensions. Yeah. I wanted to get the cost, but they want the dimensions. So x is 4. So if x is 4, what's y got to be? 5. I like it. So 4, what was it? Did I put it there? Yards, right? 4 yards. Y is 5 yards. What would the cost be? Just to ask that question. Here's the cost function, right? I could just put a 4 in here. So it'll be 100 plus 100, it'll be 200 bucks. All right. Now I know, anyway, let me see if I can push this a little bit. Did we end up with the square? No, we didn't. But watch this. This is cool. Why didn't we end up with a square? Because the costs weren't symmetric. You can see that? One cost was different than the other 3. I'm not going to, it's sort of like one side is not there for a river. It's not going to be a square. But there is a way this is a square. This is kind of nifty. What's the total cost just here? This would be 25 times 4, right? So the x dimension cost $100. How much did the y dimension cost? 5 times 20, $100. So 100 this way and 100 that way. So, I don't know, this is so beautiful to me. It could just be me, but the answer is still a type of square. Even if you had a problem where you had one side was a river, if this was 20, these will be 10s. So it's like this side isn't here. This would have normally been 10, 10, 10, 10. Since this side doesn't here, the 10 goes up on that side. It's not a square, but you can still see the square idea in it. And that probably is just me, but it's really kind of nifty. Even with cost and weird shit, it still works. Now, what about this guy? Have you guys tried this one out yet? There are several problems in the homework that are like this. This one would have that little image. That means you can use a calculator, because you can't really factor that thing, but it's kind of nifty. Some of us might not know where the hell to start with this thing. What's the distance formula? And I say squared distance, you'll see why. What's the distance between 2 points, x1, y1, and x2, y2? What's that formula? So if I have 2 points, how do I see how far apart they are? Well, if I know this distance and this distance, I can use what theorem? Pythagorean. I love it. So the difference in the x's squared plus the difference in the y's squared has to be the distance between the two squared. Now, I've mentioned this earlier this semester. I don't want to take a big-ass square root. Can you imagine that would create an ugly-ass chain rule? All that shit inside of a square root. I don't know why. If I minimize the square distance, doesn't that minimize the distance? Yes. So I make a square distance function. Now what am I going to plug into here? What are my 2 points? So here's x squared minus 1. And here's the point 2, negative 1, just think of it as a visual. Can you guys see that? That's not bad. It's a little sketch. Can you guess where the answer is? I mean, for my sketch, it looks like the answer might even be 1. Where's the distance going to be minimum? Well, it's kind of like at a slant over there, so it's going to be somewhere in the middle. That's where the distance is going to be closest. This kind of problem is related to, we see a frickin' asteroid, we know its trajectory, what's the closest it's going to get to Earth? That's this math right here. Now that's 3-dimensional, so it's going to be more like 281, but it's basically this in 3 dimensions instead of 2. You guys semi with me. And of course, if that's like 0, that's where we have to send up a bunch of old people, go up there and mine shit, and Ben Affleck and whatever, and all that stuff happens, right? If you've never seen the movie, that's probably not a bad way to be, but no? Okay. I'll stop. So the way we do this is, do I know what the answer is? Do I know what that point is? No. So what do I call it? XY. What is y, though, if it's going to sit on the parabola? What's y for any point on the parabola? What's the definition of the parabola? For any x, what's the y? You could do this. Yes, x squared minus 1. That's what. Any x I have, when I plug it in the function, I get x squared minus 1. And we've seen this before, where you write a point with all the information in the point. Y can't be anything it wants to be. It has to be x squared minus 1. So I want the distance between this point and this point. So take a minute. Can you just throw all the stuff in here? See what you get. You got the difference in the x's, the difference in the y's. Throw it in there. See what you get. Make sure everybody's looking at that correctly. Doesn't it x squared minus 1 minus negative 1? Negative 1 cancels. So you end up with, this will be x squared, this will be x to the 4. Let me put that first. Plus x squared minus 4x plus 4. So that is the function that I want to work with. Because if I can minimize that function, that also minimizes the distance. So I've created my distance function. I can now work with it. And this is where you got to realize, I'm not going to do implicit bullshit. I'm not going to do 2D deeper. No, I want to take the derivative of the square distance. The derivative of the square, and what is the derivative of the square distance? What's the derivative? Four x cubed, 2x minus 4. Now, is that a form that we can factor. Not necessarily. We could try synthetic, but to be honest, to cut to the chase, the answer is not nice. So it's not going to factor nicely. So here's where things get really nifty. All right, so here's the parabola. And there's 2, -1. So the closest thing, it looks to be maybe if I zoom in just a bit. Let me zoom in to here. Yeehaw! Woohoo! Okay. So here's 2, -1. 2, -1. There's 2, -1. All right. Oh, this is a horrible scale, Jeff. Ah, screw it. Let me go back to normal. Now, so here's 2, -1. So the closest point looks to be around 1, like we said with my gross, well, not horrible sketch, right? Now here's what's really cool. If I plot this guy, what do I want to do with this guy right now to get the answer? What do I need to do with this? Set it to 0. And I know I can't do this by hand. So if I put this in the calculator, you see where it equals 0, pop, right about where we thought it should, right? So again, how do I get that in the calculator? Well, if you don't know, it's bad, but if I do second calc, I can calculate the 0 of that red line. Let me make sure I'm on the red line. There I am. I want a left bound. So under the answer, I want a right bound, so over the answer, and I want them to guess, and I get that. 0.83 something or other. Wow. You could have done that, Jeff, a long time ago. 0.835, blah, blah, blah. Which is close to 1, which is what it looked like in our little sketch. It looked like it should be something close to 1. Okay, maybe. So that means what point? So it'll be 0.83, get out of there. 0.835. Now here's what's really cool on the calculator. Watch this. I need the point on the parabola, right? So let me see. I should be able to handle this. Yeah. If I just hit the down button, I've now shifted. See how now it's blue? Now I'm on the parabola. So what's the point of the parabola? 0.835, comma, 0.303 it looks like roughly. Approximately. Holy crap, Jeff. Let's zoom out. So that is the point on the parabola that comes closest to the point 2, -1. I like it. Okay. Let's try out some more. Let's see what time it is. Yeah, let's try out one more of these optimization problems. Maybe we'll try to see if we can put 2 in there. I'm going to take one right out of the book. Here, all right. Well, let's do another geometric problem. That one looks like it could be funkadelic. We have to do that kind of problem, yes. Okay. There are several problems in the book about inscribed shapes. So if I said inscribe a circle inside of an equilateral triangle, that would be an equilateral triangle with a circle in the middle, right? I like it. So that's inscribed. If I said inscribe a triangle inside of a circle, that would be like that. Yeehaw, woohoo. I like it. And I could have like a question where I have a triangle inside of a circle. What's the maximum area of the triangle? Well, why would there be a maximum area? Because I could have a triangle, several different shapes. It could be like that. It could be like that, right? And they would each have different areas. Yes, it has to touch. Every vertex of the thing that's inscribed needs to touch. If I inscribe the circle inside of a triangle, though, it just has to touch each side of what it's inside of. I like it. Okay. So let's do one like that. Let's do that. And this one sounds really nifty. So the area of the largest rectangle. So area of the largest rectangle inscribed in the ellipse This one's going to be a lot of fun because they don't give us any numbers. I don't know any dimensions of the ellipse. So I know we have different definitions of fun. First off, just draw that. Can you draw it? Now, it doesn't have anything about which orientation the ellipse is bigger in, whatever that, so it doesn't matter. It doesn't matter. I'm just giving myself a bit of a snapshot anchor to kind of work with. So I would do it like this. I'm going to make mine more like a standard UFO. And I put the little rectangle in there. Wee-haw. Woohoo. All right. That's terrible, but oh well, it's good enough. So this is where students, and I cannot blame you, but maybe you can draw and they're like, what the shit do I, well, okay, that's great. What the shit do I do? You need, I know I want the area of that. That's what they ask me. And they tell me it sits in this stupid ellipse, right? So I have to somehow use what they tell me in what they ask me. So let me see one thing. All right. Where do you want to put, I want to put a coordinate system on this thing. Where would you want to put the origin? In fact, where does the origin have to be considering this equation? Is that shifted at all? No. So the origin's got to be at the middle of the ellipse. I like it. Now you have some leeway over what you call things. Can anybody tell me what are the most important points of that rectangle because they somehow deal with what the problem tells me? And this was kind of pointed out earlier in a way. What are the most useful parts of that rectangle? The corners, because they actually have to live on the ellipse equation. Whatever the corners are, have to work in that equation. In fact, what's really cool about that corner, now watch this. So what do I want to call this distance here? I'm crazy. I would call that x. Because I'm crazy. Which means this whole thing would be 2x. That's amazing. All right, I like it. So what does that mean this is? This height. Because what, let me see if you guys can do this. What is this point here? This is the point x comma what? Oh shit. Well, what's it supposed to be? X comma y. But I'm not going to put a y there. What am I going to put there? Do you know what y is? What did we do on the last problem? What did I put where y was? Oh, is that the right? Here. What did I put where y was? I put what y is. Okay, well what is y? What do I have to do to figure that out? Solve for y. I like it. So what do you get when you solve for y? It'll be 1 minus this. Square root both sides. And square root of b squared is b. Multiply that up. Just to cut to the chase. Is that cool? Subtract that over. Take a square root. Multiply by b. It's plus or minus, but the way I've drawn it, that's going to be the positive part. And I'm dealing with distances at the end of the day, so yeah, I like it. Maybe. So what is the height? The height, well, just this piece here, right? Just this piece right here is going to be that expression here. It's going to be b square root of 1 minus x squared over a squared. So, I want you to realize what am I doing right now? What function do I have to construct to be able to answer this question? I have to construct a function for what? What are they asking me to do something with? The area. So I've got to construct the area function for my rectangle, and it can't just be frickin' x times y. It's not enough. There's too many variables. It can't work with that. So I'm using what they tell me. It's got to live in this ellipse in what they ask me. So this little bit right there is going to be b square root of 1 minus x squared over a squared. So what is y going to be? I mean, what is this side of the rectangle going to be? Twice that, right? So 2b square root of 1 minus x squared over a squared. So my area is going to be this times this. So it'll be 4bx square root of 1 minus x squared over a squared. So if you have something living inside of something else, sometimes the useful thing is the radius. Maybe it fits in somewhere. So if I had, for example, if I had a rectangle live inside a circle, then the radius might come in handy, right? But I can also just treat it as these corners have to live on the circle equation. I can do the exact same thing I'm doing here. Okay. So eventually that equation for the thing this sucker lives in has to come into play. So I've constructed the area for any rectangle that lives inside this ellipse. So what would the next thing be that I would do? I've created my function that I need to work with. So how do I work with it? What do I do? What's the question asking me for? The area of the largest rectangle. I've got an area function, so what am I going to do with it? To find that largest area. How do I find the location of the max or min anything? I have to take derivative. So forget all the weird shit we had to go through to construct this function. I don't care where the function comes from. How do I maximize it or minimize it? Get the derivative, get the critical numbers. So a lot of times you get stuck in, oh, this is all weird. It came from a weird place. I don't care. It's a function that came from a weird place. But how do I optimize it, maximize, or minimize it? Take a derivative. I don't care where it came from. This derivative is going to be a little gross. Now, I don't know if some of you guys would realize you could use the trick we did earlier with the distance. You could square both sides. Because if I can maximize the squared area, that would maximize the area itself. Or we could just work with this directly. So if I do A prime, it's going to be a product rule. So it'll be 4b times 1 minus x squared over a squared to the 1/2. Plus, now I got to take a derivative of this. The 1/2 would come down. Now it's to the, that should be 1 minus negative 1/2 times the derivative of the inside. So now it really shouldn't be horrible. Now it's just taking a derivative. So A prime equals 4b times this business. Let's see what we get here. Minus, where'd my 1/2 go? Oh yeah, I already did that. So minus 4bx squared over a squared times this. That's how we got it. Okay. And what do I want to do with this now? Besides, forget about it. Is that equal to 0? Where would this thing be undefined would be, you could see in here, when x equals a. So that, I don't, maybe you guys can see. Let me slow down. One critical number would be where this thing is undefined. What's the only piece of this that's kind of like on the bottom? That involves a variable, this guy. Right? So when is 1 minus this equal to 0 when x is a? So one critical point, one critical number is x equal to a. Okay. I like it. What you'll, okay, so let me write that down. So one critical number is x equal a. Okay, I can see that already. Let me put it over here. How do we get the other critical numbers? I have to set this thing equal to 0. And I already can feel a lot of you guys have given up on this poor little dude. It's got a lot of shit in it. Right? I'm going to set this thing equal to 0, though. So I can see a couple of things that are going to... 4b, it's going to die. I can just divide both sides by 4b. Why? Because b is a constant. You with me? I can add this piece over. And this is what you got to get used to with seeing these kind of things. So let me see. 4b's die. So I get 1 minus x squared over a squared to the 1/2 equals, let me add this to the other side, x squared over a squared times 1 minus x squared over a squared to the negative 1/2. Now I can multiply both sides by something that will get rid of all my radicals. What would make this die if I multiply by what? What do I multiply x to the negative 1 by to make it become 1? X. Yes. So what do I multiply this by? Make it become 1? 1 minus x squared over a squared to the positive 1/2. So do it to both sides. That kind of thing happens all the frickin' time. So on this side, this becomes 1. On this side, these two halves become a whole. Oh. And now I'm almost there. If I add this over, multiply by a squared, divide by 2, take a square root. Let me see, what do I get? I get divide by 2, take a square root. I get a over square root of 2. That is just freaking nifty. No, I purposefully, that's kind of one of the hard intermediate problems in this section, right? This is not supposed to be really easy, and you knew from the beginning it was going to be a little gross to kind of keep track because they gave me no dimensions of the ellipse. They were just A and B. So I'm not going to get a number answer here, right? A and B are going to be involved in this. So here we got what x has to be. X has to be a over the square root of 2. Now tell me real quick. Now look, why can I, let's go back. This is the last thing I'll talk about with this. Why can I eliminate this option? Can anybody tell me what A has to do with this ellipse? Anybody remember anything about ellipses? This would have center 0, 0, and how far out in the x direction would I go? Anybody remember? What's the biggest x could be, considering I can't use complex numbers? If I want to have x squared over a squared plus something equal 1, what is the biggest x could be? Would be when this is 0, right? And if this is 0, x has to be a. So a is the distance you go out from the origin. So a is how long this stupid thing is. So if x is a, I end up with a line. That's not the answer. That's no area at all. So that's kind of like the minimum area would be if I let x equal a. I just get a line. Sort of like that. I have a one fence. I don't really make a pen. It's not going to hold anything. I can ignore that shit. Where'd it go? Die. So this must be, if I make it a over rad 2, if I go out a over rad 2, that makes the rectangle that lives inside the biggest. Whatever A is, whatever ellipse you got. Woo! All right. Now, a lot of the problems in the homework are easier than this one, but they have the exact same steps. They tell you something, they ask you something, use what they tell you in what they ask you to make the function you need to work with. Cost, distance, area, whatever. Okay. So I gave everybody a practice test, right? Okay. So the problems like the one we just did are buried in number 7. The one that says page 360. So a few of those are going to be, I think 4 of those are optimization problems. I like it. Okay. So Thursday I'll have the quizzes graded. I'll have the answer key for this.